So this was a vectors question. We've given some information on a couple of points on the line. And the first one is to find the distance between points A and B. This is a sort of question you could have honestly had at GCSE. So what we're going to do is find distance between these two. If you're thinking in terms of vectors, you can just find the vector A to B. So that's going to be 4 subtract 3, 0, take away negative 2, 1 take away 5. And then all we're going to do is find that distance. And that's root 21. And you can do all that in one step if you want. So it's just find the difference between each part of the coordinates and do some Pythagoras, but in 3 dimensions. That's the extra bit. Verify that B lies on line 1. So that means we can use what we have been given. So all we want to do, here is the coordinates of B, and I'm just going to make that equal to my line. So that's the position vector, that's R. Okay, so that's basically what I'm doing. So what you get from that is you're going to get 3 equations. Okay, so this equation, you can easily see that tells me lambda is -1. If you solve these equations, they also tell you lambda is -1. Therefore, B lies on line 1 when lambda equals -1, as it gives all the same. Okay, so our next bit is we've got line 2 and we want to find lines L1 and L2 that intersect at a point, and that's going to be point C, and show that A, B and C form an isosceles triangle. So we've got point B here. Well, the first thing that might be useful to do is find point C. So to find point C, I'm going to take my 2 line equations and make them equal to each other. From that, I'm going to get 3 equations that I want to solve simultaneously. Okay, so I want to solve this simultaneously, and I've only got 2 unknowns, so I actually need to solve 1 pair of them. Now you can do this in your calculator as long as you rearrange them such that lambda and mu are on the same side. So for example, that wouldn't be 9. That would be 3 take away 6, so that would be -3. And then they will be in a format whereby you could put them in your calculator simultaneous equation mode to find lambda and mu. And what you'll find from there is lambda is 2, mu is 1. It's always worth, you don't need to in this question because they're not going to check trick you, and it's not to show that, but it's worth checking in the last equation, and that way you'll know if your values are right. Once we found lambda and mu, you pick one of them. For example, mu equals 1, and we're going to put that into the appropriate line equation, which is line 2 in this case, or you could put lambda into line 1, and this will let us find the coordinates of C. Right, so the coordinates of C is 2, 1, -3. All we've got to do then is do the same technique that we did in part A to find the lengths of the sides. So we know that AB is root 21. Okay. Now you know C, we've got B and A from earlier. So 3, 5. Okay, and B being 401. Okay, all you've got to do is do the same technique we did in part A to find the lengths of the other sides. If you do that, you'll find the length of BC is root 21. It doesn't matter if you find AC as well, you'll find that's different. So two sides have the same length. Therefore, isosceles triangle. There is an alternative which you could do it with angles, but as we don't have any angles at the moment, that's going to take a bit more work. But you should be able to find that two of the angles are 20.2 degrees, which is angles A and C.